lambda upon 2 pi small r equals to lambda upon 2 pi r epsilon. Therefore, E is inversely proportional to R and graph will be as shown. This is formula for intensity near infinitely long wire. Can I clear this?
Yes.
Yes.
Then write electric field due to cylinder. Electric field due to cylinder. First one, solid conducting cylinder. Solid conducting cylinder or hollow conducting cylinder, all are same. Solid conducting, hollow conducting, or hollow non-conducting, one and the same cylinder. So three formulas will be of same. Solid conducting, hollow conducting, hollow not conducting. Heading written.
Yes, sir.
Yes, sir.
See, whenever you give charge to cylinder, if it is conducting, all charge will come on the surface. If it is hollow, then also it has to come on the surface. Hollow non-conducting, then also it will come on the surface because there is no medium inside. So I'm just clearing this part. Heading I am clearing. Huh? Let sigma be charge per unit area of the surface. This is also called as surface charge density. So if this is cylinder having radius r, it is charged with surface charge density sigma. So by using Gauss's theorem, we have to find what is intensity at any point inside, outside, and on the surface. So just draw this diagram. Case 1, point lies inside. Now if point lies inside and I draw a Gaussian cylinder such that it is having radius r, so it will pass through point P. Point lies inside means distance from axis is less than radius. What is charge enclosed by this Gaussian sphere? A Gaussian
Zero
cylinder,
by
pardon?
zero.
0, correct. Charge enclosed is 0. So intensity E into ds by Gauss's theorem, it is Q upon epsilon naught. This is called actually flux. So Q is 0. That means can I say E ds ka integration is 0? Area cannot be 0. So who is 0? E is 0. Hello?
Yes, sir.
So intensity at any point inside the hollow charge sphere or solid conducting cylinder or hollow not conducting, intensity inside is 0. So I just copied it. Chalo, can I clear this?
Yes, sir.
Case 2. Point lies outside. So this is cylinder charged uniformly. Its radius is r. Here point lies outside. So r is greater than r. Now if I draw Gaussian cylinder of height L, radius r, it will pass through point P where intensity is directed outward. So flux total will be flux phi 1 plus phi 2 plus phi 3. 1 means this curved surface, 2 and 3 are upper and bottom plane surfaces. This is nothing but total charge inside upon epsilon naught. Flux of first one, first take this one, second this, third this curve, will be 0 plus E bar dot A bar, dA bar. That is nothing but E dA cos 0. So E integration of dA. Therefore, this will be E. What is total area of this curved surface? Is it 2 pi RL? Hello?
Yes, sir.
2 pi RL. So therefore, we get Q inside upon epsilon naught is E into 2 pi RL. Now, in terms of sigma, if you take, then Q inside will be sigma into area 2 pi RL or not? Tell me. Q is sigma into area. Area of this cylinder on which charge is present is 2 pi capital RL. Hello?
Yes, sir.
Yes, sir.
E into 2 pi RL in sigma. 2 pi you can cancel, L you can cancel. So E equals to sigma capital R upon epsilon naught into small r. Write this, then I'm converting this in lambda. Point lies outside, so we can have a Gaussian surface which can enclose the charge on the cylinder. Therefore, total flux is flux due to outer plane, lower plane and curved. Plane surface is 0, curved is E bar dot dA bar. E and area vector both are in same direction, therefore cos 0.
सर
हाँ,
सर वो टोटल फ्लक्स वाला एक्सप्लेन कर दो ना, 5 1 + 5 2 + 5 3 कैसे?
ये अपना सिलेंडर है बराबर। तो फ्लक्स इधर से इधर से इधर से ये देखना है ना हम लोग को।
अच्छा हाँ ठीक है।
इधर इधर तो चार्ज नहीं है तो नो फ्लक्स। क्या ई और इसके बीच का एंगल 90 है तो भी 0।
90 cos 0।
हो गया, क्लियर हो गया इधर तक।
हाँ सर।
नाउ वी गॉट ई एज सिग्मा कैपिटल आर अपॉन एप्सिलॉन नॉट स्मॉल आर। तो इसका अगर ग्राफ इफ आई ड्रॉ, point is outside, inside we got 0. So till r equal to radius there is no intensity. As soon as capital R small r becomes same, then this will be E maximum, that is sigma upon epsilon naught, and then it will be inversely proportional. This will be the nature of graph. अब यही formula E is sigma r upon epsilon 0 r. I am converting in lambda. Sigma is charge upon area 2 pi r. Therefore sigma E equals to sigma, which is q upon 2 pi rl r epsilon 0 into small r. This will get cancelled. What is q by l? Lambda into 2 pi r epsilon. Same we got now. Near infinite long cylinder. Hello?
Yes, sir.
So
Yes.
whether you take wire or infinite long cylinder or cylinder, inside it is 0, outside formula will remain same for both. So you can write in sigma, you can write in charge, you can write in lambda, but I will prefer you remember in this form, lambda upon 2 pi r epsilon. Sigma we can convert whenever we require. So right now copy till this, but we will convert and remember in this format.
Done, sir.
Even graph done?
Yes, sir.
Non-conducting solid cylinder. Non-conducting, then charge is inside entire volume or entire space, you can say. So in this case, if this is cylinder which is non-conducting having radius r, then charge will be distributed throughout. It will not be on the surface. Distributed throughout. So here we say rho equals to charge per unit volume. I am interested in intensity inside and outside. If we want intensity inside, point lies inside. So if point is here, now if you draw Gaussian surface, it will enclose the charge. If charge was on the surface, then point inside it was not able to enclose the charge. Correct, ma?
Yes,
So
sir.
Yes.
now if point is inside, it is going to enclose the charge. So just draw the diagram, then I am doing further.
Done, sir.
Now point is inside, charge is enclosed by that Gaussian surface. So by Gauss's theorem, Q inside upon epsilon naught is total flux. Flux from first plane surface, second plane surface, third curved surface. So this will be 0 plus 0 plus only due to curved surface. Write these three lines. Done?
Yes,
Yes,
sir.
sir.
So now I can say Q inside upon epsilon 0 will be only phi 3, which will be intensity E into curved surface area 2 pi r of the Gaussian cylinder. Correct? Hello? But
Yes, sir.
Yes, sir.
what is meaning of rho? It is charge per unit volume. Rho is charge inside upon volume. Volume of cylinder which is having radius r, length L. Can I say pi r square L? Hello?
Yes, sir.
So our Q inside will become rho into volume inside wala pi r square L upon epsilon naught is E into 2 pi RL. We can cancel L, we can cancel 1 R, we can cancel pi. Therefore, we get intensity E equals to rho R upon 2 epsilon naught. Rho R upon 2 epsilon naught is intensity at any point inside the non-conducting charge cylinder. That means we can say E is proportional to R inside. See, everywhere we were getting inverse, either square or R. Here we are getting directly proportional to R. So just copy till this, then graph I am drawing. So if point is inside non-conducting solid cylinder, E is rho R upon 2 epsilon naught. 10 times you will write, then only you will remember. State board में नहीं है ये topic. Written?
Yes, sir.
Inside this time it is not 0, but it is rho R upon 2 epsilon naught. Case 2, point lies outside. So this is cylinder which is non-conducting solid, charge is inside, point lies outside. So if we enclose it by Gaussian surface, of radius small r is greater than capital R. Now we can say charge inside upon epsilon naught. See, this surface will be 0, this surface will be 0, curved surfaces E into 2 pi RL directly there. Q inside is nothing but sigma rho. This time volume will take pi small r square or pi capital R square?
Capital R square.
Capital R square into L upon epsilon naught is equals to E into 2 pi RL. L pi cancel. So we get E as rho capital R square upon 2 epsilon naught into small r. Totally different formula if it is not conducting cylinder. Right, full.
Done, sir.
So what will be the nature of graph? Till r equals to capital R, E was directly proportional to R, correct now? And then inversely proportional. So this will be the nature of graph. Hello?
Yes, sir.
For non-conducting solid cylinder.
Done, sir.
Next, write electric field next heading electric field due to plane sheet of charge. Plane sheet of charge means infinite sheet of charge. Last class we wrote direct formula sigma upon 2 epsilon naught. Now we'll check whether it is true or false. So if I consider a plane sheet on which charge is sigma. That means consider an infinite plane sheet of charge, plane sheet of charge having having surface charge density sigma. Consider a cylinder having area of cross section dA and P is a point at a distance x from the sheet. So we have drawn one cylinder having cross sectional area dA and length 2x, total length. So P is point at distance x. It can be on the left side, it can be on the right side. So intensity will be directed outwards in both the direction, which is along dA bar. So this is the direction of E bar, same is direction of dA bar. On this side also positive charge means E bar is directed outward. Hello? Hello?
Yes, sir.
So can I say by Gauss's theorem, total flux is Q inside upon epsilon naught. Total flux means flux phi 1 plus phi 2 plus phi 3. This is nothing but phi total. एक मिनट जगह नहीं है, इतना कर लो पहला. Plane sheet, charges will be on both the side. So I have taken point P, it can be on the right or left, and drawn a Gaussian cylinder, cross sectional area ds, and its distance is x from the plane sheet on either side.
सर इसमें phi 3 परपेंडिकुलर होगा तो वो 0 हो जाएगा.
Either
और
phi
phi 1 और phi 2 रहेगा.
yes. Can I clear this diagram?
Yes.
But phi total is phi 1 plus phi 2 plus phi 3. See, phi 1 and 2 are plane surfaces. So this time from plane surface we'll get E dA cos 0 का integration plus E dA cos 0 का integration plus phi 3 0. Nothing is from curved surface because E and A will become perpendicular. So phi total will become E integration dA plus E integration dA. This is nothing but 2 times E integration dA. EDA means 2 EDA. That is nothing but 2E dA. We have taken area, total area only. So all small area is A. Therefore you get Q inside upon epsilon naught equals to 2E into area A. Q inside is nothing but sigma into total area A. Correct ना? हेलो,
Yes.
ये मैं समझा ना, ये ऐसे बनाया था शीट इधर से.
Yes, sir.
तो ये एरिया हो गया ना इसके अंदर, E into its area which is dA or A one and the same for us into epsilon naught 2EA. A I can cancel. So we get E equals to sigma upon 2 epsilon naught. So if you remember last class, I used one problem was there. I saw 3 sigma minus 2 sigma wala yaad hai kya? So I took sigma upon 2 epsilon naught, 2 sigma
Yes,
upon
sir.
2 epsilon naught based on this.
Yes, sir.
So this becomes our intensity near plane charge sheet is sigma upon 2 epsilon naught. Copy till end. Important for 12th standard board, 12th board. If you complete, tell me.
So
Done? Okay. This is one plane charge sheet having charge plus sigma. Is another plane charge sheet having charge density minus sigma. There are 3 points A, B, and C. Find what is EA, EB, EC. We have to find what is EA, EB, EC. Now, if you look carefully, one plate is positive or one sheet is positive, other sheet is negative. So magnitude wise answer will remain same, but direction will be reverse. So for this positive at point outside, this will be the direction. E due to first one outward,
Yes, sir.
yes, sir.
and this side this will be outward. This much you have followed.
Yes, sir.
Yes, sir.
And for negative, what will be the direction? Inward.
Inward.
So inward, inward, and this way inward it will come. Correct, na? From both sides. Okay. Direction followed.
Yes, sir.
Yes, sir.
So this is one ka outward, ye two ka inward. Here inward, inward. So what you see at point C, they are equal opposite, no? This is
Yes, sir.
E1, this is E2. So can I say at C, resultant intensity will be 0? So E1 equals to E2. Therefore, resultant will be 0 at C
Yes.
because they are outside, right, left, opposite. At B, what you can say? Again, E1 is same as E2, but direction is opposite. What about resultant? Is it 0?
Yes, sir.
At A, E1 is same as E2. They are in same direction.
Yes, sir.
So,
Two. Yes, sir.
resultant will be E1 plus E2 or not? Hello?
Yes.
That means it is sigma upon 2 epsilon plus sigma upon 2 epsilon.
Yes, sir.
So finally what you will get?
Sigma upon
Yeah,
epsilon.
2 sigma upon 2 epsilon, which is sigma upon epsilon. Very important even for CBSE in board, and for NEET also it is very important. Everybody has followed the concept?
Yes, sir.
Yes, sir.
Copy all with diagram properly. At C, direction is opposite, but magnitude is same, 0. At B also 0, but in between it will be addition of E1 and E2. Aryan, I did put minus sign, you followed na? Minus is for direction we are taking.
Yes, sir. Done. Sir.
Okay. Next is non-conducting sheet of large surface area and thickness is D. Volume, charge density is rho. So whenever you see non-conducting, we always take charge as volume charge because it lies in the space, not on the surface. So suppose this is thin sheet. Thin sheet, thickness is D and charge is inside. This is the meaning of that. Draw diagram. Find electric field intensity at point P inside. Non-conducting sheet, point P is inside. We want what is intensity. Can I clear the diagram?
Yes, sir.
Yes, sir.
So just I am showing you the diagram of front view, enlarge one to understand the meaning. That means this is that sheet of thickness D. Charge is inside. So if I again consider a Gaussian cylinder, of length x on either side of axis, intensity will be this way, directed outward because it is positive charge. Okay,
Yes, sir.
so this is E directed outward from both sides. Now flux total is phi1 plus phi2 plus phi3, and total flux is charge inside upon epsilon naught. Flux phi1 will be E into area dA cos 0. Phi2 is also same, E dA cos 0, and phi3 will be 0. Are you clear? Phi3 is 0.
Yes, sir.
What is charge inside? It is rho into total volume of Gaussian cylinder.
Pi r square L.
No, area we have taken A na, this area. Pi r square area A
Yes.
और ये thickness आएगा ना, LL. ये XX
Yes, sir.
तो total 2x is length, total area suppose A upon epsilon naught, वही pi r square L जैसा ही. So this is A, total area is E, total area A, E, total area A. So it becomes rho 2xa upon epsilon naught 2ea. Both side 2 we can cancel. A we can cancel. So we get E equals to rho x upon epsilon naught for non-conducting sheet. Rho x upon epsilon naught. Now copy full. If paper is difficult, such things will come. So you have to keep in mind the formula. So point is inside, thick sheet, then rho x upon epsilon naught. Rho is nothing but charge per unit volume.
Done, sir.
Done. Everybody is done?
Yes, sir.
Yes, sir.
Now point lies outside. If point lies outside that sheet, charge is inside. Now if I draw Gaussian cylinder, then this will be intensity E bar, intensity E bar. This is total thickness D, and from axis, this distance is x. Okay. So Q inside upon epsilon naught is 2EA. Same formula, only charge. Let us see how much it will come. Rho into area A. We should write this time charge enclosed only this much. Na?
Yes, sir.
So it will be only D or it will come X?
D.
Only D.
Only D. Upon epsilon naught 2EA. A cancel, therefore E equals to rho D upon 2 epsilon naught. Rho D upon 2 epsilon naught. Copy. First was rho X upon epsilon naught. This is rho D upon 2 epsilon naught. Completed?
No, sir.
आराम से आराम से डिफिकल्ट है थोड़ा ये क्योंकि 12th वाले को नहीं है ये बट एनसीईआरटी बुक में है
Done, sir.
Everybody has done?
Yes, sir.
Yes.
So if point lies inside the plane non-conducting sheet of thickness D, then E we got as rho x upon only epsilon or 2 epsilon?
Epsilon.
Rho x upon epsilon. If lies outside, then E is rho d upon 2 epsilon naught. Now I want graph of, okay, please write this separately again. Inside then rho x upon epsilon naught, outside then rho d upon 2 epsilon naught.
Done, sir.
Okay. Graph of E versus distance x. E versus distance x. If point is here, what is x then? D by 2 or not? Hello?
Yes, sir.
Yes, sir.
Point is inside, so maximum it will be till x equals to d by 2. So till x equals to d by 2, point lies inside. In that case, we are getting rho x upon epsilon naught. Na?
Yes, sir.
That means it is linear graph where E is rho x upon epsilon naught. Correct? Linear graph E is proportional to x.
Yes, sir.
And outside what you are getting, if point is outside, what is E formula? Rho d upon 2 epsilon naught. Correct?
Yes, sir. Constant
Very good.
parallel to x-axis.
Yes, aa jayega. Constant. It is rho d upon 2 epsilon naught. Copy properly. Inside the linear, outside it is constant, which is parallel to distance axis. Done?
Yes, sir.
Okay. Next is electric field intensity due to charged spheres. Again, when I say charged sphere means there are two category of sphere. One is hollow. It is sometimes also called thin shell. Shell means nothing but hollow sphere. Thin shell or hollow shell, which can be conducting, that is metallic shell, or it can be non-conducting, same formula. Non-conducting or metallic, same to same. Here it will be conducting solid sphere or non-conducting. Hello? Hollow. This
Yes.
is solid, conducting or not conducting. This A, B, solid, conducting, हर एक के लिए same formula आएगा. Charge will be on the surface. खाली solid non-conducting का charge will be inside. Hello?
Yes,
Yes,
sir.
sir.
Just write down, then I am writing where the charge will be on the surface. Done? Except for non-conducting solid sphere, except for non-conducting solid sphere, the charge remains at surface. So except for non-conducting solid sphere, charge remains at surface. That means for this hollow, conducting, non-conducting, solid, conducting, formula will remain same for inside, outside and on the surface. Only for non-conducting it will change. Can I clear this now?
Yes, sir.
First one. Electric field due to hollow. When I say hollow, it can be conducting or non-conducting, one and the same. Conducting or non-conducting, same. And solid conducting is also same. In all the cases, charge will be on the surface, solid conducting. So if we consider a sphere with center O, radius R, whether it is hollow conducting, hollow not conducting or solid conducting, charge will be on the surface. So case 1, point lies outside. That means R is greater than R. Point lies outside. So if we draw a Gaussian sphere with radius small r having same center, then intensity will be directed outward. Hello?
Yes, sir.
Yes.
To small elemental area. So can I say flux, which is nothing but Q inside upon epsilon naught. This flux will be E into area dA into cos 0 will be charge inside. If you take sigma, then charge inside will be sigma into 4 pi r square. Sigma into 4 pi capital R square upon epsilon naught. Correct?
Yes, sir.
That means E into total area of the Gaussian sphere is 4 pi small r square equals to sigma 4 pi capital R square upon epsilon naught. 4 pi cancel. So E equal to sigma capital R square upon small r square into epsilon naught. Obtained till this, then I am converting this in terms of charge. Sigma means charge upon area. So many times they ask relation between sigma into capital R's. See, have you understood now what we have done? We have taken sphere,
Yes.
then enclosed it by Gaussian cylinder sphere here. We are finding charge inside and electric flux. That's it.
Done, sir.
Everybody has done?
So one.
Uh,
Yes.
so E equals to sigma r square epsilon naught small r square, or E equals to sigma is charge upon area, which is 4 pi capital R square into R square upon epsilon naught R square. That is nothing but E equals to 1 upon 4 pi epsilon naught Q upon R square. Same we are writing now for sphere. See, if point lies outside a hollow sphere or non-conducting conducting solid sphere, same formula we were writing. Hello?
Yes, sir.
Yes, sir.
If point lies inside, then what is charge enclosed? Q inside is how much? 0, na?
0.
So E will be 0 or not?
Yes, sir.
Yes.
And if point is on the surface, point on the surface, then small r becomes capital R. Therefore, E will become 1 upon 4 pi epsilon Q upon capital R square. So this is for inside, outside, inside on the surface. Okay, for sphere. So maximum time you will get sphere, and if paper is difficult, then cylinder or sheet will come. Yes, copy properly till end. And solid non-conducting, if you remember, we have already done rho r upon 3 epsilon naught if point lies inside.
Done.
एक छोटा सा और कर देता हूँ, फिर विल स्टॉप. Total there are 4. Actually it is only 2 case. 3 is same. So next one is electric field. Electric field due to solid non-conducting sphere. In this case charge is inside. So just remember here, charge is distributed inside. It doesn't comes on the surface. So let rho be charge per unit volume of sphere. Please copy this much. Then I'm drawing the diagram. Then again we'll consider 2 point inside outside.
Done.
Case 1, point P lies outside. So distance of point is greater than sphere. This is sphere, charge is inside, point is outside. So if I draw Gaussian surface of radius small r, then this is direction of intensity through that area dA. What will be flux here? Is it E dA cos 0? Hello?
Yes, sir.
That
Yes.
means E integration of dA. What is dA? 4 pi small r square, correct? Huh? And Q inside upon epsilon naught. How much is Q inside? Rho into 4 by 3 pi r cube. Hello?
Sir,
Yes.
capital R cube.
Capital R, correct. Rho into 4 by 3 capital R cube upon epsilon naught, equation 2. Now equating we get E into 4 pi r square rho into 4 by 3 pi r cube upon epsilon naught. 4 pi cancel. So E equals to rho capital R cube upon 3 r square into epsilon naught. 3 epsilon naught r square. Point inside, outside, then rho r cube 3 epsilon naught r square. Copy.
Done, sir.
Everybody has done. Can I clear?
Yes,
Yes, sir.
Yes, sir.
So we can say or E equals to rho means charge upon volume 4 by 3 pi r cube into r cube upon 3 epsilon naught into r square. So r cube cancel. 3 cancel. So is it same as 1 upon 4 pi epsilon naught q by r square? Same आया ना? So if it
Yes,
is
sir.
hollow or it is solid cylinder, non-conducting, point is outside, formula will remain same. Copy. Then inside wala will do. Inside I think I have explained you once again, we'll see. Case 2, point lies inside. So this is original sphere whose radius is capital R. R is less than small r, so point is inside. Then this much is the charge enclosed. So this time it will become flux equals to Q inside upon epsilon naught. Flux is integration of E dA cos 0 equals to Q inside. Q inside is rho into 4 by 3 pi small r cube this time, not capital. Clear na? Hello?
Yes, sir.
Yes, sir.
So this is E into area dA is rho 4 by 3 pi r cube upon epsilon naught. Today only you write once again in rough notebook, then formula will be clear in your mind. Because in entrance we are not interested in derivation, we are interested in knowing formula and application of the formula. Now E into dA, which area you will take? Gaussian wala, which is 4 pi r square, correct na?
Yes, sir.
Yes.
Equals to rho into 4 by 3 pi r cube upon epsilon naught. Pi 4 r square का ये r गया, so E becomes rho r upon 3 epsilon naught if point is inside. Whereas if it is if it is conducting hollow or conducting solid, then intensity inside was 0. Here it is coming rho r upon 3 epsilon naught. Copy this.
Done, sir.
Today I will stop here. Please revise and be ready and try to complete. How many sums we have done in MCQ?